So correlation as a term refers to a mutual relationship between two or more things. Formally in statistics, it refers to the interdependence of variables. What does that mean? Well, it means that, for example, if something influences something else, you would expect a positive correlation. So you can expect a positive correlation between temperature and ice cream sales, because when it's hot, people buy more ice cream. So as the temperature goes up, more ice cream is sold. Or conversely, you could expect an inverse correlation, or a negative correlation as it's sometimes known, between temperature and sales of gloves. So when it's hot, people buy fewer gloves. So as the temperature goes up, less gloves are sold. But there's a very famous saying, I'm sure you've come across it, or if you haven't, here it is: correlation is not causation, meaning that just because two things are related doesn't mean that one causes the other. Okay. And now in the two cases I've given you here, actually, it is quite likely that the temperature causes the sales of the ice cream. So as the temperature goes up, people buy more ice cream. As the temperature goes up, people buy fewer gloves. But that's not necessarily the case. So, for example, as ice cream sales increase, so do cases of sunburn. Okay, so you could say they are correlated because they both go up at the same time. Okay, but eating ice cream doesn't cause sunburn. Having sunburn might cause you to eat more ice cream to cool yourself down, but eating ice cream doesn't cause sunburn. So you can't really say there's a causation between one of those two things. Probably, in this case, it's easy to see there's probably an underlying causation, which is the sun's out, the temperature's high, people buy more ice cream and get sunburn. But don't assume that just because you see correlation between two variables, it means that one is causing the other. You can't make that assumption. There's a whole, this is such a famous saying, there's a whole list of examples on Wikipedia. I don't always recommend Wikipedia because some of the information is a bit suspect, but this is quite a nice list of examples if you want to take a look at that page. Okay, so how do we assess correlation? Well, one standard way is with these scatter plots, and we use that to visualize them. And if you take any two variables, so A and B, and I picked A and B here because our products, A and B, we can use those variables with common index values, so the dates. So we can pick AB, AC, AD, but they don't have, they could be any two variables that have common things like ice cream sales and temperature. Now, obviously, those are two, they're measured very differently, but if you've got a maximum temperature on a date and the number of ice cream sales on a date, then that's two variables that have common index values, the date being the index value. And what do you do to do a scatter plot for each index value? So for each date, in this case, you plot one variable along the x-axis against the other variable on the y-axis with a small dot at the location AB. So AB is the place, so I don't know, the sales are 300 on the 1st of January and the sales of A are 300 and the sales of B are 500 on the 1st of January, then the location A, 300 along the x-axis, 500 up the y-axis would be the location of a small dot. And if you do that, you'll get something like this. So you just get, for every pair of values, or for every index value, rather, you get a dot. So in our case, if we take our products, we're going to have 365 dots. And you plot them on a chart like that, and if you get something like the one in the middle, the one that says no correlation, that means there's no observable correlation. You can't see, they're randomly scattered, so the variables are not correlated. And then there's degrees of correlation. Obviously, the straighter, if you get a very close together straight line, that means they're very strongly correlated up to perfect correlation. And if it's going upwards, left to right, and if it's going downwards, left to right, then we call that perfect negative correlation. And then there's degrees of that in between. So the more scattered they are, the less correlation there is. The straighter the line there is, the more correlated they are. Okay, and we'll see that in some data later. That chart came from a Maths is Fun website. So first thing then, if we want to check correlation in our set of data, we have to pick pairs of pairs of variables, which in this case refers to our product. So we've got A to Y, 25 products. We've got to pick a pair of those products, maybe A and B, and then visualize them. So why don't we start, now we've identified the high volume, we did that 2 weeks ago, we could just start with those. So A, F, and L, we could pick pairs of products. So we could pick A versus F, A versus L, and F versus L. So that will give us 3 plots in total. However, if you then go to the medium volume, because there's now there's 5 variables, you need 10 plots. The formula actually is the number of variables times the number of variables minus 1 divided by 2. So we've got 5 variables, 5 times 5 minus 1, which is 4. So 5 times 4 is 20 divided by 2. And we can do this using what are called nested loops. So we have a loop that picks a bunch of first variable, and then another loop inside that picks another variable, and then we can use that to plot our different pairs of variables. But the trouble is, as you can see, if there's n items in this selected thing, as I said, the formula is half times n minus 1. So it can get, for not very many variables, it can get a very large number of plots very quickly. Anyway, let's do that for the high volume products. So here's the code for the high volume products. And you can see the selected icon is just like before. We've selected the 3 product names. The loop code, so inside the loop, inside the nested loop, this plot.figure, which you can see here, plot.figure, plot.scatter, is pretty much the same as everything we've used before. So now we're scattering data against data, but where the selected name I might be A and name J might be F. Okay, so these loops, if you're not a programmer, don't worry too much about these. You can just reuse this code straightforwardly. So the first 3 lines of code you can use straightforwardly to generate this loop of every pair in that list. So if you give me a list of variables, these 3 lines of code, the 4 loops and this name J, will give me every pair of those of the things in that list. Okay, and if we do that, we get something like this. So product A looks like it's kind of not strongly, but correlated a bit with product F. Product A versus L, they don't look correlated at all. And product F versus L looks like they're positively correlated, but not very strongly. Okay, that's the plots that we get. So that single line, I put it in there, the single line in bold actually is the thing that creates the scatter plot. So it's just taking 2 columns from this data set, from this data frame, and plotting them as a scatter plot. And the other lines, they just prepare the figure, add the title, the labels, and the title. So the key bits of this code really are the plot.scatter here. That's the thing that does the plotting, and then this loop, pair of nested loops that will generate every combination of the selected variables. Okay, I'm going to finish that video there, and then we'll move on to look at the idea of subplots and faceting.